Good afternoon. Thank you so much for coming to hear my talk on named entity recognition on log files. So I want to go right into the data we'll be processing. I will be talking in this talk about log files, and it's exactly the data our model is going to input. So some of you may know what are log files. They are a pillar of data observability, but for those of you who don't know, log files are computer-generated files that contain information about activity within an environment. It can be a server, it can be an application, it can be many things. The thing to remember is that they are generated automatically every time an event takes place in a network, right? To see a more specific example, the first one here in my slides, it's an Apache web server log. Imagine I've decided to host the website in an Apache web server, and every time I get a request, one log that has this shape is generated. I can see that I have information about the IP. I think I have indications about the time the request was made, but I see that I also have more information. And a second example, and this one is very used by companies, HDFS log files, Hadoop distributed file systems. Every time we move data, when we use them between nodes, we generate very different logs. Some of them can have this shape. So now that we know what are logs, I want to talk about the problem I'm going to try to solve. And the problem, you might have guessed it, is basically the quantity of logs that we have nowadays. Where I work at Onum, but in many other big data platforms, we ingest terabytes of log files every day. And they come from very different sources, and many of them are generated in a real-time manner. So ingesting them is a challenge for us. Also, the forms can be, there's a wide variety of forms. For example, on my screen, I have some standard formats that are quite common. Many of you are going to recognize JSONs, you're going to recognize CSVs, key values, even XMLs. Those are 4 standard format examples, but many of them don't follow any strict format. And it's a challenge also because the ecosystem is constantly growing, right? We have new technologies every day. We also need to adapt to the log files they produce. Of course, we don't only ingest them, we also parse them, right? In order to get insights from data, I need to make queries to them. And in order to make queries, I need to have some kind of structure. So that's also one of the challenges we face. Coming back just for a minute to the log we saw before, if we know nothing about it, if you don't have any prior business knowledge, you kind of think that you have a log that's separated with blank spaces. You feel that you have an IP because I told you, or maybe you know already, but you might not know that you also have information about the request, if it was successful or not, the amount of bytes it generated, or more details about the device that generated it. So we feel that it's a pretty difficult task, right? Of course, I want to say that we do parsing already. It's not that it's a new problem or anything like that, but maybe you've written parsers yourself. It's very manual. It's very time-consuming. It's quite a tedious task because it requires human effort and also domain business knowledge. It's very difficult to write a parser if you have no idea of the source that's generating the log, right? There are automatizations that are possible and that you might have guessed. For example, you could think of regexes, right? Or grok patterns that are basically super regexes in order to detect things. But even though we know they are expensive computationally, but I'm going to talk about transformers, so you will say that's also expensive. But what I want to say is that those techniques are very static. When you have a regex, a substring can match yes or no, but it will never look at the environment. It will never look around, right? So it'll make a decision only using this substring. And just to say that nowadays, there are many log input files that we are not able to treat, for example, where I work, because we're not able to adapt fast enough. We know there's useful information there, but we aren't able. We don't have the capacity. So I want to jump right into our approach to solve this problem, which is named entity recognition, NLP, right? I'm going to talk about the training methodology we used and also how we measured our model. I'm going to present some experimental results that we got, and I'm going to talk a bit more about more applications. Okay, brief reminder for those who are not familiar, what is named entity recognition is just another NLP task. It consists on identifying and classifying named entities, pieces in the text, into predefined categories that contain some properties. So when I started to see named entity recognition algorithms, I noticed they were usually detecting things like persons, organizations, locations. But I wanted to see how we can apply things like that to logs, which are the data I use on a daily basis. You could say that logs don't contain natural language, right? Or at least they shouldn't. But that makes our task easier because logs have a syntax that's very clear. They don't have a huge vocabulary. So they also have a semi-structure, right? They are automatically generated. So these seem like being kind of doable to us. Briefly, we're going to detect entities. Entities can refer to many things, but a general definition could be anything that is separate, identifiable, and has a set of characteristics. In my case, I was obviously interested in the entities we can find in logs. With my team, we made a big list of things we are used to parse, right? And I just gave you here what I think are the most frequent ones and the more useful. We talked about IP addresses before, but MAC addresses are also very common, user agents, commands, status codes, emails, URLs, IP ports, and things like that. At the same time, we have other things that we call formats. They don't mean anything. For example, JSONs, key values, CSVs, or even timestamp. They don't have a real meaning, but they can help us with the parsing discovery problem, which is one of what I'm trying to do here. So now that we've talked about entities and about the parsing, how can we mix them together? As you can imagine, when you detect something you recognize, it has a meaning. It should stay together most of the times. So you're kind of guessing what are the fields in my log, right? What are the fields of the query in the future I want to make? So if I know the things that should stay together, I can guess the separators because those are the things in between. I can guess column names and I can automatize the parsing discovery problem, which is not the parsing itself, it's the previous step, right? It's knowing the parser I need to perform. So this can give us knowledge, prior knowledge of the things we have, and we can even optimize at a prior step the things we ingest, because we understand them in an automatic way. Okay, more information on the model we developed. We know it's a token classifications task. The classes are the entities we defined. Those examples I just showed you. We know it's a supervised problem, right? It's actually a classification problem, and this is probably the first difficulty. We are going to need a labeled data set. Of course we do. Not only labeled, we'll need logs, entities, but also to perform beginning entity outside tagging for most of NER models. We know we are going to do tokenization, as we always do in NLP, and we know this can also be a problem because usually tokenization is done on vocabularies that are not optimized for logs, right? So that can also be a difficulty. We're going to have embedding. Of course, we need to convert this test into numerical vectors. But then we're going to get to the model itself. And we know that training from scratch is very expensive, so we decided to use a pre-trained model from the BERT family to do a fine-tuning and profit from transfer learning, even though we know it's definitely not trained on logs, but we showed that it had strengths generalizing on our problem with the fine-tuning we did. So at this point, we had a model that outputted predictions. It was very nice, but without a way to measure it, we knew the progress wasn't going to be very clear. So we focused on the best way to measure how our model was working. We know classic metrics for classification, right? Everybody computes false positives, true negatives, etc. We build contingency tables, and then we compute precision, recall, F1, for example. The thing is that those metrics, in our case, were useful to compare models, but weren't very intuitive at all, because we preferred metrics that were calculated at entity level, and also named entity recognition tasks are not that 100%, 0% right. More things can happen. There are more scenarios. Concretely, there are 6 principal scenarios that we were interested in measuring to assess the quality of our model. The first one is everything's working fine. The model has labeled the right entity to the right substring. We have what we know is a true positive or a strict match. On the other hand, the model can completely invent an entity. It happens, unfortunately. Or on the contrary, we can completely miss it, right? And those will be our classic false positive, false negative cases. But a named entity recognition model can also mislabel an entity. We could get it right, the substring is completely correct, but it has mislabeled to an entity that maybe is similar. It happens to us too. But we also have partial matches. Imagine the model has an idea of where the entity is, it's the right one, but it doesn't get the string all right. And finally, a combination of the previous two, a label boundary error, complete disaster, wrong entity, wrong substring. So we decided to monitor those 6 quantities by entity and globally. It was interesting to us. It seems like a lot, but it was interesting to us to have a complete control on what entities are overfitted, underfitted, what entities are colliding with each other. And just imagine that we've kept using F1 score. Imagine that for a partial match, we'll penalize it twice, once as a false positive and once as a false negative. And of course, a partial match is better than nothing, or at least for our clients. So we come to the practice slide. I talked about the data set. Unfortunately, I wasn't able to find any open source data set on named entity recognitions on logs. Logs, no problem, but no labels at all. So using the knowledge we had at my company and the amount of logs, I know that writing parsers is tedious because I did it myself, for 15,000 logs coming from different sources. We are currently working on a way to enlarge it, right? It's my main focus at the moment. And to start steadily, I started by labeling and training over 3 different entities, not 20 at the first time. I use the Hugging Face Transformer library and their hub as a model repository. To calculate those metrics, I use the Python evaluate package, and I embedded the metrics as model metadata, right? This is necessary to perform automatic model selection, of course. And what we saw is that by only keeping the entities that the model was very sure about, right? Because we had probability scores, we were very surprised to see the results we got. Partial matches were almost 100%, but also strict matches. We were happy with the latency too we got. We used AWS SageMaker for model deployment, and we got responses within milliseconds, which wasn't bad considering we're using still a DistilBERT, but a BERT family model, right? And right now, I'm actively working in bringing this model into production with everything that means, and particularly getting feedback as soon as possible from users and telemetry to perform retraining. And something that I haven't been able to do yet, but I'll do soon, is to work on nested NER algorithms. We know entities can contain some other entities. Think about URLs, think about mails. They also contain domains, right? So this, for me, will be like the next big step. So I basically talked about how this can automatize and solve the parsing problem. That's okay, that's what I do in my work. But those kind of systems, NER applied to logs, can also have other applications. I don't know if you're familiar with user entity behavior analytics or UEBA systems. Those cybersecurity systems use entities to learn patterns and then fire alerts when those behavior change. So those kind of systems can be the ground for UEBA, for example. And when security incidents happen, unfortunately they do, with such a model, we could decrease the response time of what we call log forensic analysis, which is looking into gigantic amounts of data to see where the security breach was. If we had a model that automatically tells us what are we looking at, that could solve also many problems. So I'll be very happy to hear your questions, and thank you very much.
Let's sit a bit. We have a few minutes for questions. Thank you so much. Amazing presentation, let me tell you. Whenever I think about logs, I think about cybersecurity and what we can do today in cybersecurity. So we have a few questions. I think the first one, and we have several questions about the data set that you used to label. First is about scalability. You did it for 3 entities. How do you see this scaling to many other domains?
Yeah.
It's a manual work, it's an open source data set.
No, it's not, at least for now, it's not open source, but it's definitely something we're looking at. But to really answer the question about the future, right? How I'm going to do all this work, we are actually planning on releasing this model with small one, right? With 3 entities into production, and then get the feedback from the real parsers and use the clients that configure parsers in our platform to actually label the data set for us, kind of.
Okay. A question related with this: Have you thought about using synthetic data for training the model?
Of course. Actually, right now I'm actively working on generating logs, which is also pretty useful.
Okay, good. A lot of questions on your session. Why DistilBERT and not another LLM?
Okay, so
it's a good one.
Yeah, sure. Of course, I faced also that. The answer I have is mostly empirical. Sometimes, well, it worked, but the truth is, BERT family models had all the requirements we needed, and the DistilBERT version was obviously much faster, keeps the performance, and it worked really nice. I'm actually now also working on testing smaller models, right? I think the path for me will be into the smaller transformers, especially after seeing the good metrics I got.
And changing a bit about the business case and the application of this, have you thought about what are the main domains, business domains where you can see this? You talked about UBE, but
I think it's mostly cybersecurity. Yeah, I think that knowing the entities you have on your system and being able to detect them in an automatic way can help you to have an understanding of their behaviors. So when I think about logs, I also think that cybersecurity is going to probably be the application here.
I think cybersecurity, just to share with the audience, at Microsoft, it's very important for us, and that all the big players on Microsoft on cybersecurity are looking at threat analysis and doing all parsing, and it's a very important area. But
it is
on consumer behavior, probably the same thing whenever you see that. So, okay, are the logs deleted after some years? It's a question.
That's a classic question on big data. How do you erase information? Well, retention policies vary. Customers decide them. I don't know.
Okay. And the last one, can you share some metrics for some of the entities that you mentioned?
Yep. For example, of course, there were so many numbers that I didn't think that sharing was that useful. But what we can see, for example, for IPs, which is a pretty easy task, right? To recognize an IP for a transformer, we got almost 100% strict matches on the unseen logs I use for evaluation. And for example, to talk about timestamps, because everybody that has parsed dates know it's a pain because there are 300 formats. And of course, you could do them all, but well, we weren't that good on the strict matches, right? But we were catching partially more than 90%. And I think that with some refinement, we'll be quite confident about this particular entity as well. And then the third entity, which were paths, was a bit more tricky.